Good morning, students. This is Topic 7, Periodic Trends, Video A, Atomic Size. We just spent a month studying the basics of chemistry. I hope that you are beginning to see and feel some of its wonder. As a group of scholars, we are now ready to delve more deeply into understanding atoms. Let's start by looking at the observable trends in some of the properties of the elements. These trends are often called periodic trends, but we like to think of them as elemental trends. We will look at three: the size of atoms and ions, the ionization energy, and the electron affinity. Before we explore these trends, let's reacquaint ourselves with the periodic table and the language we will use in looking at the trends. Recall that the table is arranged in groups. These are the columns in the table. There are 18 groups. We also talk about the rows, which are called the periods. There are 7 periods, plus the 2 periods of the F-block elements. When we look at trends, we can explore how a physical property changes as we go across a period from left to right. That means we stay in a row and cross groups. The atomic number goes up. We can also grow across a period from right to left. Here we are crossing the table in period 6. The atomic numbers are going down. When we use the word cross, we are going right to left or left to right. We can also go up and down a group. Here we go down group 2 and are crossing the periods from 1 to 7. When we go up a group, we start at period 7 and move to the top. The first periodic trend we will study is atomic size. If we continue to think of our atom as a sphere, then the natural measure is its radius. Specifically, we measure the bond length and then define the radius to be half the bond length. For bromine, the bond length is 228 picometers, and so the radius is 114 picometers. We can look at the atomic radii of all the atoms in the periodic table. We will exclude the transition metals and focus on the main group elements. As you move down a group, the atoms get bigger, and as you move across the period, the atoms get smaller. Here is a visual image that shows the trends in the radii of the main group elements in the periodic table. The measured radii are given in units of picometers. You might want to stop now and stare at this table. In your notebook, write down the trends you see in your own words. Let's now begin to understand why these trends occur. It is all about electrostatics as described by Coulomb's law. Here's the equation for Coulomb's law. Let's get a feel for how it works and what it means. Coulomb's law is about the force of attraction or repulsion between two charges. Q1 and Q2 refer to these two charges. Let's consider two positive charges. These charges repel and are pushed out. But what if we have one positive charge and one negative charge? These charges attract and are pulled in. Now what happens when the magnitude of the charges are not the same? Suppose we have 3 positive charges, but only 1 negative charge. The force is attractive and a lot stronger than the case when we had only 1 positive charge and 1 negative charge. Now how does all this relate to the size of the atom? Let's model the atom with the protons at the center of a circle. Put the electron on the circle. As the number of protons in the nucleus increases, the radius of the circle should decrease because the attractive pull on the electron from the nucleus gets stronger. As you go across a period on the periodic table, you increase the number of protons, and so we would expect the size of the atom would decrease as we go across. This is exactly what happens, except the atomic radii don't decrease as much as expected. Let's not forget about the electrons. As we add electrons to the circle, each one is attracted to the nucleus but repelled by the other electrons. The actual size of the atom is a balance between the pull of the electrons into the nuclear center and the push of electrons away from each other. As we go across the period, the pull of the electrons into the nucleus is greater and the radius decreases. Okay, but what happens when we go to a new period? We see the same trend across each period. Atomic size decreases as you move across the period. But as we go down a group, the radius increases, even though the number of protons is also increasing. Why is this? As we go down a group, we increase the number of atomic energy levels that contain the electrons. Each shell is larger than the prior shell, and so the size of the atoms increases. So where are we? We can use the periodic table to predict atomic size. Atomic size increases as we go down a group because the number of shells increases. Atomic size decreases as we go across a period because the number of protons increases and shrinks the electronic cloud. Now let's practice. Use only a periodic table and your knowledge of trends to rank the 4 atoms from greatest to smallest. Pause the video here and write the answers in your notebook. Here's the solution. It is important to realize that all the atoms in period 4 are bigger than all the atoms in the earlier periods, so that potassium is the largest atom. Conversely, fluorine in period 2 is the smallest atom. Sulfur and chlorine are in the middle, and we order them by realizing that the size decreases as we go across a period from left to right.